Hey, good morning, everybody. This is Mr. Aynesworth in MRWC at Great Oak High School in Temecula Valley Unified School District. And we're going to get into yet another review in Section 3. This covers up to 3B4 activity. All right. So, again, get all your resources out. Get your MRWC notebook out. Get out your activity 3B4 because that was a big one. And then use it to your advantage. And again, go at your pace, which means pause, play, rewind, and do what you ought to do. Just don't copy. A lot of people just watch videos. Some are even like so naive to think that just copying down without even listening to me will suffice, and that is definitely not the case, you guys. Okay, copying doesn't help. Just watching the video without sound does not help because I explain a lot of detailed things in this video that will help you out, and try to explain things actually so you understand. And so you want to strive to understand, and so that you can be able to pull this off on your own. So be wise, all right? Be a good student. All right, so notice it's in two-column format here. The reason why I did that this time is because the problems are on the right, left side, okay, with the steps. We can write in some steps. And also do all your work on the right side, okay? So afterwards, we can fold this document in half and use it like a note card in two-column format, kind of like semi-modified Cornell style, and use as a study tool. So problem on the left, work on the right, okay? So here we go. Let's write down the distance formula first. So the distance between 2 points A and B, which we call A and B, okay, the distance AB, that's from geometry right there. Okay, is the square root, all right, of the quantity x2 minus x1, quantity squared, plus y2 minus y1, quantity squared, which simply means is you subtract the x coordinates and square it. You subtract the y coordinates and square it. And then you add the results, and then you square root it, okay? This is derived from the Pythagorean theorem. All right, you could also use the Pythagorean theorem if you want, okay? And be my guest if you want to. All right, so what I'm going to do is I'm going to line up the points first. That could be a step one. Okay, so line up points. Vertically. So let's do that on the right-hand side because like I said all the work is on the right. And then what that does, if you line them up, is it lines up the x-coordinates and the y-coordinates. Because one of the most common mistakes people make is they get them all mixed up, all right? And then all you have to do is subtract up. Okay, so that upward arrow means subtract up. So here we go. Here comes the distance formula. So you start off with the square root symbol, and you start off with the x-coordinates, okay? They're the first coordinates. So you start off with the second one, subtract the first one. That's what x2 minus x1 means. And you take 2 minus a negative 4. So notice I said 2 minus a negative 4. And then you square it, and then you start off, then you switch or transition to the y coordinates. Okay, well, the y coordinates, well, the y coordinates in an order pair always come second. And so what you want to do is you want to subtract them, starting with the second one. So 5 minus 1. Whatever that is, you square it. Notice that I continue with the square root symbol because I haven't square rooted the answer yet. 2 minus negative 4 is 6. And then you got to square it. 5 minus 1 is 4, and then you got to square it. And so you got 36 plus 16. That's a square root of 52. Now at this point, what you want to do is you want to factor. So if you're with me, if you're one of my students, you know how to factor. All right, so 52 divided by 2 is 26, divided by 2 is 13. That's prime. So the only square factor is 4. Okay, so this is the square root of 4 times the square root of 13, which happens to be 2 rad 13. Okay, and there's your answer. And when you practice something like this, you practice just like this, step by step. Keep the symbols on mathematical. Keep the equal sign down there. I mean, make it look good, guys. You're trying to get good, and you're trying to be really successful for your test, so you practice correctly, practice perfectly, okay? Vincent Barty said that, by the way. All right, perfect, or practice doesn't make perfect, but perfect practice makes perfect. All right, so learn it, remember it from Vince Lombardi, not me. All right, now you try it. Okay, so let me give you a couple of new points. So let's call it C. So A, B, C, D, right? So alphabetical. So let's say it's 3, 6, point D. And let's say it's 1, 12. Okay, just making that up. All right, let's work it out. So find the distance between C and D now. So start off with the square root and go for it. Pause the video now. All right, pause it, work it out, and when you're ready, press play. Okay, here we go. We're going to subtract up again. I always start with the x-coordinates. Every point, the x-coordinates comes first. As you guys know from Algebra 1, all right, x-coordinates come first, and that goes first. So you take 1 minus 3 squared plus, and then the y-coordinates. Gotta subtract those two, right? They come second. Okay, so let's take 12 minus 6. We're going to subtract and square. So here we go. So negative 2, 1 minus 3 is negative 2 squared plus 6 squared. That gives me 4 plus 36. That's the square root of 40. Now 40 is a square root of 4 times the square root of 10. Why? Because 4 times 10 is 40, people. And you get 2 rad 10. So always simplify the root. Simplify the root. Okay? Always do that. All right, let's highlight that, okay? There we go. That's for you girls, okay? Right there. All right, purple. Okay, all right. Rockin' and rollin'. All right, next one. Okay, so number 2, we got to simplify the roots again. So the first thing you got to do is you got to factor the roots. And let's do it on the right-hand side. Okay, so here we go. Let me write the original problem first. So 5 root 18 minus 2 root 72. Okay, so here we go. 5 times the square root of 9 times the square root of 2. All right, I factored the 18. Obviously 18 is 9 times 2. Now you could have picked 3 and 6, but they're not squares, so that'd be a bad choice. So don't pick 3 and 6. If you did, think again. You always want to pick squares. All right, you got to pick squares. Okay, 9 times 8 is 72. You could start off with that, or you can take 72 off to the side and find a bigger square other than 9. So 72 divided by 2 is 36. Ooh, there's the square right there. I'll continue just for fun. Okay, so if you're watching, if you're my student, you know what I'm doing. So there's 4. There's 9. 9 times 4 is 36. And like I said, 2 times 36 is 72. So you want to square root those. So the square root of 36 times square root of 2. This gives you 5 times 3 times rad 2. And this gives you 2 times 6 times rad 2. Again, I'm simplifying the roots. That's another step. Okay, and then we're going to simplify it a little bit. 5 times 3 is 15. I mean, a lot of this is just basic math, people. 2 times 6 is 12. And if you start off with 15 rad 2s and you take away 12 rad 2s, it kind of sounds like you have 13 rad 2s left over. So you simplify again. So you keep on simplifying. Okay, there we go. All right, now your turn, right? You guys have got to try it as well. All right, so let's do that. Let's try it here. Let me just push this off to the side a little bit. Now you try it, okay? All right, now your turn. Okay, so how about 3 root 12 minus 5 root 8, okay? Now pause the video, go for it. All right, so you got to factor the 12. So 3 times root 4 times root 3 minus 5 times root 4 times root 2. That gives me 3 times 2 times root 3 minus 5 times 2 times root 2. That's 6 root 3 minus 10 rad 2. And my friends, these are unlike irrational numbers. Okay, so you cannot combine unlike roots. Okay. All right, that's it, man. All right, let's keep on trucking, as they say. All right, number 3. We got 2 of them. All right, it's number 3. The first. Let's do the easy one first. Let's take it off to the side. Again, everything happens on the right side, right? Right. Okay, so let's let's rewrite the problem. So 3 divided by 2 rad 5. And the key step here is you want to multiply it by the same root, okay? So multiply by a form of 1. So multiply, all right, by a form of 1. All right, what do I mean? Well, you multiply by root 5 over root 5, because we know when we multiply roots, identical roots, here's the key concept right here. Root 5 times root 5 is root 25, which is simply 5. So notice there's no root anymore. Okay, when you multiply identical roots, there's no more radical symbol. Okay, that's the reason why we do this. Okay, so 3 rad 5 up top. Okay, root 5 times root 5 is 5. 2 times 5 is, well, I'm going to write it as 2 times 5, and then simplify. And as you get good, obviously that you just write the answer. So it's 3 root 5 divided by 10. All right, now you try. It's your turn. Okay, so you try it now. So how about this? How about 5 divided by 3 root 2? Okay, pause the video. Go for it. Now it's your turn, right? Your turn. Pause the video. Go. Okay, I'm going to assume you've done this. So let's multiply it by rad 2 over rad 2 in the form of 1. Again, this is called a form of 1 because root 5 is 1. Root 2 divided by root 2 is 1. Anything divided by itself is 1. Okay, so what do you get? Well, you get 5 rad 2 up top. Root 2 times root 2 is 2. 3 times 2 is 6. And you are done. Okay? That's as easy as it gets, people. All right, you just have to practice and get good. We did a lot of this before. Again, it takes a lot more practice than you guys realize. Okay? All right, now, the conjugate of this. Okay, so let's talk conjugate. So, let me see. So, the square root of a plus b, the conjugate is the square root of a minus b, and vice versa. So I'm going to put a double arrow there because all you do is change from a sum to a difference. Okay, I'm going to refer to this as the conjugate. Okay, so what I want to do is I want to take this problem, I want to bring it over here. So 3 divided by rad 7 plus 4. I'm going to multiply it by a form of 1. So using the conjugate, root 7 minus 4. Root 7 minus 4. Now these are binomials, so give them all a hug. All right. All right, put parentheses around them here. Distribute through the 3 up top. That's the easy part. 3 rad 7 minus 12. All right, 3 times root 7 is 3 root 7. 3 times 4 is obviously 12. Now the denominator here is a difference of squares. And so you can see the structure. A plus b times a minus b, and that's always equal to a squared minus b squared. So this is the square root of 7 squared minus 4 squared. So you get 3 root 7 minus 12 up top, divided by 7 minus 16. All right, root 7 squared is 7, 4 squared is 16. And so my final answer is 3 root 7 divided by 12, divided by negative 9. Okay? And that's all there is to it. You know what? Whoops, sorry. Sorry, technological error right there. We got to reboot. Give me a second here, people. Yeah, so technology is great when it flows. So right now I'm running a video, and sometimes it glitches. Like right there, you just saw a glitch. So just give me a second here. I'm just redoing things. Okay, I'm just reformatting here so I can have a little bit more room. Okay, so now your time is to try it. Okay, so here we go. Let's try 5 divided by the square root of 3 minus 2. All right, let's again do it over here. So write down 5 divided by root 3 minus 2. Multiply it by a form of 1. Okay, pause the video and go. Okay, let's check your work. So the form of 1 we need is the square root of 3 plus 2 divided by the square root of 3 plus 2. And again, put parentheses around everything. These are binomials. Okay, so what do we get? Well, you got to distribute through the 5 twice, right? So you get 5 rad 3 up top plus 10. 5 times 2 is 10. And then again, this is a minus b times a plus b, and it's always equal to a squared minus b squared. So I got to take the first term and square it. I got to take the second term and square it and simplify the result. So I get 5 root 3 plus 10 up top. Nothing to do up there. Square of root 3 is 3. The square of 2 is 4. And so I get 5 rad 3 plus 10 divided by negative 1. So you divide both by negative 1, you get negative 5 rad 3 minus 10. Because when you divide both the positive numbers up top by negative 1, they change sign. All right. All right, moving on. Here we go. So number 4. So all straight, okay? So let's take 5 rad 3, okay? And you want to square this number here. You want to square it. There's 2 ways to do it, okay? If you go back to basics, 5 rad 3 squared means 5 rad 3 times 5 rad 3. And what that means is that you got to multiply the 5s and you got to multiply the rad 3s. You got to multiply like terms. Okay, so let me write that out. So this part, multiply like terms. So I just rearrange, okay, regroup, right? Because the order in multiplication does not matter. Okay, regrouping and ordering in multiplication doesn't matter. So what you do, all right, just simplicity speaking here, is you multiply the like terms, 5 times 5. Then you multiply the roots because those are the irrational parts, okay? And then you get a result. So obviously 5 times 5 is 25. Root 3 times root 3 is root 9, which is just 3. And so the end result is 75. Oops, not 72, 75. Okay, so there we go. Now you try it. So now take 7 root 2 and now square it. Pause the video, go. All right, let's check it out. So 7 rad 2 times 7 rad 2 is equal to 7 times 7 times rad 2 times rad 2. And that gives you 49 times 2, or 98. Now, the other way to do it, just so you know, the fast way, and this is the AND approach, right? Step-by-step AND approach. So AND would do it like this. All right, here's what Simon would do. Simon would just square both. 5 squared times root 3 squared to get 25 times 3, which is obviously 75. That's what Simon would do. That's what I do, okay? So just remember that. That's the fastest way to do it. You can write it out and step it out like AND would, or you can use structure and understand the properties of exponents and just square both terms. Totally up to you. All right. Now, a little bit more difficult. Squaring a binomial. This was hard for you guys in class. Okay? Squaring a binomial. Now this is in lesson 3b4. Okay, so I'm going to go back to 3b4 and just show it to you, because you might as well use your notes, right? Right. Okay. So I just got to find it here. Oh, this is the activity. I need 3b4. Let me see. Hang on. Okay, here it is. This is the prep. 3b4 prep and activity. What we want to do is find the square in a binomial. Here it is. Here it is, right here. Okay, so this is 3b4. All right, look at this. Squaring a binomial. You got a square. Okay. You got a square multiply double square. So this turns out to be a trinomial. And the most common mistake people make here is that they don't multiply double, and I'm talking about the middle term. Okay, so let me just say something right here. 2x minus 3 squared does not equal, all right, 4x squared plus 9. Okay, this is a common mistake. I see it all day long, even with my calculus students. So don't just square both of them, because obviously you missed the middle term. It's negative 12x. You got to square, multiply, double square. Now let's get back to the lesson here. Okay, so here we go. if I can find it. So here we go. All right, so I just did a little time warp right there. Okay, now let's do it right. We're going to square. Here's the key. Square, multiply, double, square. All right, and then you're going to get 3 terms. All right, 3 terms. It becomes a trinomial. All right, so using the structure, here we go. So I'm going to take 5 rad 2 minus 3. I'm going to square it. I'm going to take 5 squared to get 25 times root 2 squared, which is 2. 25 times 2 is 50. So I got to square the first term. You square the 5 to get 25. It's 25 times the square of 2. Excuse me, the square of root 2, which is 2, and 2 times 25 is 50. Minus, because there's a minus sign. 3 times 5 is 15, so I get 15 rad 2. You got to multiply and double it. When you double 15, you get 30, so this becomes 30 rad 2. And you square the negative 3, you get 9. Now, if you don't like doing that, you could do it the Ann way. I mean, this is how Simon would do it, okay? Ann would not do it that way. She would take 5 rad 2 minus 3 and multiply by 5 rad 2 minus 3, and she would step it out using FOIL. And if you want to do that, go for it. Okay, I'm not, but that's what you could do. All right, now you guys try it. So let's take a different one here. So let's take, it's your turn now. So 6 rad 3 minus 2, and let's square it. Pause the video and go for it. Okay, 6 squared is 36. Root 3 squared is 3. So the first term is going to be 36 times 3, which is 90 plus 18, or 108. So I'm going to write down 108 here. Then you multiply the 2. 6 times negative 2 is negative 12, and double it. You get a negative 24 rad 3. And then you square the rad 2 to get 4 right here. And then you simplify. 108 and 4 is 112. All right, minus the 24 rad 3. Oh, and I just looked at the previous one here. I forgot to simplify it. So 50 plus 9 is 59. So 59 plus, minus 30 rad 2. All right. That's how you square a binomial. Okay. Now the next one, you gotta have difference of squares. So this one is a difference. I've been doing this all day long here. Difference of squares. So this is a minus b times a plus b, and that's always equal to a squared minus b squared. So let's work it out. All right, so I got to take the 4 rad 3, and I got to square it. And I got to subtract the root 13 squared. Well, let me see. I get 16 here. 4 squared is 16. Root 3 squared is 3. The square of root 13 is 13. And so I get 16 times 3, which is 48, minus 13. That sounds like 35 to me. Okay? So what you want to do is use structure. All right? Be like Simon. Use structure. All right? Be like Simon. Okay? All right. Okay, now your turn. So now let's say there's let's say 7 root 2 minus root 5, okay? And then times 7 root 2 plus root 5. Okay, same idea. Go for it. Pause the video and try it. Okay, let's check your work. I'm going to take 7 rad 2 and square it. I'm going to take the root 5 and square it. 7 times 7 squared is 49. Root 2 squared is 2. Root 5 is 5. 49 times 2 is 98. Minus 5 is 93. So there you go. That's all there is to it, guys. Rocking on. Okay. We have a little bit more to do. This is a little bit longer than I thought. Okay. So the next one here, we got to simplify here. Simplify the root 4, which is obviously 2. So I have 12 minus 3 and 3 halves. So let's see here. what I want to do is I got to subtract both. So it's 12 minus 3 halves. That's 9 minus 3 halves. And that's obviously 9 minus 1.5. Okay, 9 minus 1 is 8, minus a half more. Sounds like 7 1/2. Okay, that's all you do. And that's rational, by the way. That's a rational number. Now you try it. 14 minus 2, and let's say 3 divided by root 16. Okay, pause the video and go. Okay, so now we've got 14 minus 2 divided, or 2 and 3/4. That's 14 minus 2 minus 3/4. And that's 12 minus 3/4. Sounds like 11. If you take out 3 out of 4, there's 1 out of 4 remaining. Okay, so you get 11 and 1/4. All right. Next one. Here we get the cube root of negative 125. Well, I know that negative 2 cubed is negative 8. Negative 3 cubed is negative 3 times negative 3 times negative 3, which is negative 27. I know that negative 4 cubed is negative 4 times negative 4 times negative 4, which is negative 64. So I know here that, and I know that negative 5 cubed is negative 125. So that tells me that the cube root, okay, of negative 125 is equal to negative 5, which is an integer, okay? It's an integer. It's not a whole number, it's not natural, okay, but it is an integer. All right, and it says classify. Classify means name. So the 7 1/2, that's rational, okay? The negative 5 was an integer. That's what I mean by classifying right here. And then right here, it's an integer. And this right here, this is a rational number because 4 times 11 is 44, plus 1 is 45, 45/4. That's an element of Q. Okay, the quotient, okay, rational. Remember, Q stands for rational set. Okay, so what you want to do is you want to simplify and then classify. Simplify and classify. Step 1, simplify. Step 2, classify. Okay, next one. All right, let's distribute. Actually, no, let's use structure. Okay, once again, this A minus B times A plus B, and which is A squared minus B squared. So rad 8, right? Squared minus 5 squared. That gives you 8 minus 25, and that's negative 17, and that is an integer. Okay, now like I said, if I'm going too fast for you guys, you have to slow down. You got pause and play, and you go at your own pace, because if you just copy and you don't understand, this is not helping you. You're actually wasting your time. So you got to try to learn to understand, okay? Strive to understand, and that way you can pull things off on your own. So this one here, 3.75. Oh boy, I said all repeating decimals are rational, and you really can't simplify this. This is done. So this is just a rational number here. Okay, all repeating decimals are rational. Now this one here is the same thing as the square root of 22 divided by 24, which is the square root of 1/12. And that's the square root of 1 divided by square root of 12, or 1 divided by root 12. And then let's see here. This is equal to 1 divided by root 4 times root 3, which is 1 divided by 2 rad 3. And then you just rationalize. Okay, and so we've done this before. So you rationalize, and you get rad 3 divided by, let me see, root 3 times root 3 is 3, times 2 is 6, and you're done. Now this one right here is not an element of Q. Okay, this is called an irrational number. All right, root 3 is irrational. So it's an irrational real. Okay? Okay. Next one. When you deal with negative exponents here, what you do is you rewrite it using positive exponents first. And because 3 times 3 times 3 times 3 is 9 times 9, or 81, This is actually equal to 181st, and this is a rational number, so it's an element of Q. All right, it's rational. All right, and last one here. Again, we're doing a lot of difference of squares here, guys. This is a minus b times a plus b, and this is always equal to a squared minus b squared. So all you have to do is take 11 and square it, take your 5i and square it. You square both and subtract. Okay, so you get 121 here, and you get minus 25i squared. Okay, and then what you get is 121 minus 25 times negative 1. Remember, I squared equals negative 1, okay, in the complex field. All right, and so you get 121 plus 25, okay, which is 146. Okie dokie, artichoke, there you go. All right, and off to the races. Last one, okay, last problem of the review. Here we go. Okay, now again, I'm going to use structure here. This is a minus b times a plus b. Notice the terms are the same, but one's a sum and one is a difference. Okay, so if I'm not clear, look at this. Root 5 plus 2, those terms are the same. So the first terms are the same, and then the second terms are the same. The second terms are b, and the first terms are a. This is called a difference of squares, and it's always equal to a squared minus b squared, as I've said probably about 20 times in this video. So what you want to do is use structure, all right? You don't have to. You can be like Anne, okay? But this is called a difference of squares, as I've been talking about extensively. Okay, so here we go. I'm going to take the first term, which is root 5 plus 2, and I'm going to square it. I'm going to take the second term, root 11, I'm going to square it. Now we got to be careful here. This second one here, this is squaring a binomial. And I've talked about this already today. So let's go back and let's look at when we did it. Squaring a binomial. Okay, so here we go. It's this one. So you square, multiply, double, square. Okay, so you have a middle term here. So you got to be really careful here and know what you're doing. And if you don't want to use structure, well, then you use FOIL. Okay, you can be like Anne if you want. It's okay with me. All right, but we're going to get three terms here. I'm going to square, multiply, double. Double means times 2. And then I'm going to square the last term. Okay, so here we go. I square the root 5 to get 5. I take 2 times root 5 is 2 rad 5. I double it. I get 4 rad 5. And then I square the last term. Square of 2 is obviously 4. Then I square the root 11. And then all you do is that you add like terms. And you might be asking where the like terms. It's the rational ones. 5, 4, and minus 11. 5 and 4 is 9. Minus 11 gives you negative 2. And then you have to add the irrational part right there. The 4 rad 5. And then again, you cannot simplify these, okay? So these are unlike terms. This is a rational number plus an irrational number, and you can't combine. Okay, and that's all there is to it. All right, but I think you need to do one more example here. Okay, so now this is your turn. So root 3 plus 5, okay, minus rad 2, and times root 3 plus 5 plus rad 2. Okay, let's do it over here. Now, just like the previous one, guys, pause the video and go for it. All right, let's check your result. Again, this right here is A, this is B. So A minus B times A plus B is equal to A squared minus B squared. So you square both and subtract. Square both and subtract. That's all you do. That's the key concept right there. Okay, so here we go. I'm going to take root 3 plus 5. I'm going to square it. I'm going to take the root 2 and square it. Again, look at the structure. I keep saying that. Okay, if you're one of my students, there you go. Been like sound like a broken record. Okay, and now you're going to square the binomial. So you square the root 3 to get 3. You multiply 5 and root 3 to get 5 rad 3. Double it, 10 rad 3. And then you square the 5 to get 25. And then you square the root 2 to get 2. And you simply add. 3 and 25 is 28. Minus 2 is 26. Plus the 10 rad 3, and you're done. Okay? Now this is a full review. But what's important is that you guys go back and you practice to master. So just because you went through a review with me doesn't mean you've mastered it by any means, because I have 30 years of teaching experience. So you guys have got to do what you need to do. Okay? So that's a full review up to 3B4 without the constructions, that is. All right, and I see you in my next lesson here, guys. Take care. This is Mr. Aynesworth. Bye-bye.